That's a funny voice prompt.
Zoom has been dropping me occasionally. So if I disappear, I'll come back on in about 30 seconds.
Oh man.
Yes, but I've been teaching all day and sort of been dropping me a few times during the class. I don't think it's Zoom, I think it's my internet. I just need to see if I can get a better connection.
I see. I think I'm being throttled. My internet. We're getting about half of what we used to get in terms of
right.
download speed.
Yeah.
I think it could be because of the load on the network.
Yeah, I'm sure it is. I think just like so many people are trying to do this at the same time, that yeah. But I think just need to be patient and just flow with it. I think I saw a Comcast truck just down my street this morning, so I think they're probably, I don't know if they're trying to fix stuff or trying to break stuff, but but I think they're trying something.
I see.
This meeting is being recorded.
Hi, everyone. If you're coming in and have questions before class, you're welcome to ask anything. Hi, Eddie.
Hi. The investigation number 5, are you looking for a formula for part 2?
I just need an explanation of what happens for different n values. Like you could say, oh, if n is a multiple of 3, this was what would happen. If n is like a multiple of 3 plus 1, this is what I would do. Or if n is a multiple of 3 plus 2, this is what I would do. So more like a kind of explanation of the different cases.
Okay, because I came up with the first player can win for any n not a multiple of 3 by forcing the second player into a multiple of 3.
Right, by taking the either 1 or 2, however many that they need to take. Yeah, so that's basically a not like a math formula, but it's like an explanation of the strategy. So yeah, that's what I'm looking for.
Okay, and then I didn't see any updates on the project 1. Has there been any updates on that?
Yeah, I'm postponing it. So basically, I put on the project 1 that projects are postponed for now.
Okay.
So no updates. What I'm thinking of doing, we'll see what happens after spring break, but I don't think we'll come on campus right after. So it's gonna, I'm not sure if we might come to campus before the end of the semester, but it might be a few weeks like this. So I'm thinking of just having one project for the class instead of 2, and working on the projects individually rather than in groups. So you'd probably be doing like the same amount of work, but just cutting it down to one project only. And I'll make that due towards the end of the semester, so we can sort of readjust.
Okay.
Okay.
Professor?
Yeah.
Could you explain number 7 on the quiz?
I'll do that during class time. I'll take some quiz questions during the class. I want to wait until like everybody comes in, because I'm sure they would like that too.
Yeah. Okay. Thank you.
I'll write it down so I don't forget. You can remind me.
So for project 1, do we have to post on discussions?
So project 1, I'm gonna postpone the projects for now. Okay, so don't worry about project 1.
Yeah.
I'm thinking of just giving you guys one project for the semester instead of 2, and making it individual. So let me see. Give me a bit of time. Like after spring break, I'll tell you guys what to do for the project. So I'll make it do at the end of the semester and just have one project.
Okay, thank you.
Okay.
Professor, this is Jeremy. You have not collected it is investigation 5. You've not collected that, right?
Right. Some people gave me investigations 4 and 5 before all this happened.
Yeah.
But if you didn't submit it, either of those, if you didn't submit them on paper, you or the partners that you were working with can scan it in art, can take pictures and submit them in Canvas. So I made those investigations that you can submit stuff online, so you can upload them. I think I put the due date to be tonight.
Tonight, okay.
Yeah,
I did complete it. I believe I did on paper though, so I'd have to scan it in.
Yeah, just or you can take a picture with your phone too.
All right, thanks for the flexibility.
Sure.
Hey.
Hi.
Whoop.
Cool. How's it going?
Pretty good. Looking sharp today.
Yeah, I just had a shower. I woke up pretty late.
Nice. Do you remember if we submitted our investigation 5?
You're doing investigation 5 and I'm doing 4, right?
Yeah. Well, we both worked on them, but I think
Yeah,
I
you
have
could.
to find the paper. I'm gonna look in my backpack right now.
Yeah, I pretty much have investigation 4 finished. I just have to make sure everything's correct and then I'll submit it.
Yeah, you can upload those in Canvas if you didn't give me the paper version in class.
Mm-hmm.
Oh, hi, Professor.
Hello.
Okay, you can hear me, right?
Yes, I can.
So my question is, do you know whether I submitted the investigation number 5? Because I'm confused. I feel like I submitted everything. I already got a grade for investigation 4, but I'm just confused. Should I do it again or?
So you don't have a grade for investigation 5?
I don't have, yeah? I did.
I'm not sure. I'm asking you.
Well, I just don't remember whether I submitted or not, because from my memory, I feel like we've done three of us, our group. We've been thinking about it. We've been playing with the.
I don't see an investigation 5 for you, a grade or a submission.
Mm-hmm.
Who was in your group?
Two other guys.
Yeah, okay.
But we submitted it by paper, so I.
I graded all the paper ones that I had.
Oh, okay, so that means that we didn't submit. Okay.
So, yeah, it means that I don't have it.
Good to know. Thank you so much.
If you can like redo it and submit it online, that'll be great.
Yeah, sure. Thank you so much.
Sure. All right, so I think class is starting. All right, so welcome everybody to back to discrete math after the break last week. I hope you're all doing well and staying healthy and social distancing as much as you can. I think I'm having a hard time with that because I like to be outdoors, and I also like to go to Vaughn's just to check it out. Sort of interesting to see which shelves are empty and which are not. So, but I'm trying to be good. So yeah, you guys stay healthy. So we're back in session after the break, and we're going to do the class remotely for as long as we have to. So I wanted to kind of talk about how I've changed the course a little bit to allow us to kind of work remotely a little bit better and kind of stay flexible, because if we figure like things are not working very well, then I can readjust things and sort of make it work better. Over Zoom, like if you look at your Zoom screen, at the bottom there's the controls. So this might not be the first class that you've had with Zoom because it's Tuesday afternoon, but I'll just sort of give you an orientation. So when you enter, I have you automatically muted with the mic in the video, so we don't get too much feedback. If I sort of hear background noise, I have control over everyone. I have power. So if I hear any background noise, I'll start muting you so it doesn't interfere with other people. You can see that there is also a green button there that says share screen with the arrow pointing up. So everybody has access to that button. So feel free to sort of use that. Like if you have a question on a quiz problem and here's the work I've done so far, I don't know where I'm stuck. Basically, you can share that either from your computer or your phone. So like if you have work as a picture or as a document.
Oops.
Damn, that sucks.
And
she said she was having connection issues.
Okay.
Hello.
Yeah, hi. So yeah, this will happen throughout the class. I will disappear because I don't know if it's just my internet or everybody's overusing it right now. but I've been dropping off. But unfortunately, it's kind of just comes on within a few seconds. So just gonna be patient. If I disappear, I'll just sort of pick up. I've sort of been. I'm not even getting frustrated with it anymore. I'm just sort of okay, happen again. Okay, so just keep in mind that I'll disappear occasionally. All right, so okay, so share screen. Now there's a chat button. So there's a chat also. So if you kind of click on the chat, then you can chat with each other. And that's good to ask me questions or you to kind of chat with each other, sort of participate and give answers. That's good. Okay. Now I'm recording the meetings. All right. And I'm going to, once the meeting is done, it saves to my computer and then I'm going to upload it to YouTube and link it in Canvas. So basically you have access to the recording for these meetings. And you can go over them after class to kind of, if anything was not clear, you can sort of go over and look at them again. Okay. Any questions so far? So let me share my screen and take you to Canvas. So I'm going to go over the Canvas shell. So this is our course. All right, so what I want you guys to check periodically is the announcements. I'm gonna kind of try to put things, send you stuff over email, but I know with my email, things get lost just because I forget it's there or I can't find it. So there's sort of, if you're kind of unsure of what's going on or sort of, when did you say that was due and stuff like that, the announcements are always a good idea. So I'm going to try to post at least one announcement per week that kind of gives an overview of the week. I might post more, kind of give information about tests and particular assignments and so on. Okay. So this welcome back announcement I sent on Friday. So I said that I'm gonna change a couple of things. Okay, so but some of the things are the same. So you can complete the quizzes as usual. So you can either do them on paper or type them up. If you're able to print the quiz and write on the quiz, you can just sort of print it paper. And then you're going to scan it or take pictures, or I have a thing called Tiny Scanner in my phone that takes pictures and makes one PDF so you don't have like too many files going on. And then you're going to submit it in Canvas in the quiz area. Okay. What's different remotely? I want you to pre-watch the lecture videos and take notes in your own time. And then before we meet in the live session, because during the live sessions, I want it to be more that you guys get to ask questions about quizzes and things that you've seen on the lecture. And I think it will be more productive that way because I don't get to see you in person like before and after class that you can ask me questions. So lecture is lecture. You can sort of watch it anytime, but sort of live interaction is sort of, it's not that we don't have that much live interaction. So it's better if we kind of reserve it for questions. Okay, if you don't have any questions, I'll lecture and I'll do examples that I think are good. But if you have questions, I would rather go through your questions. Okay.
Will you be meeting with us on Thursday, or are we just working on the test on Thursday?
I do have a scheduled meeting on Thursday, so I know sort of tradition, like if you're in class, that would just be a test day, but because we sort of lost some time and I want to make sure to cover the course content, I do have a live session schedule for Thursday that I want to go over some of the other sections. I think section 3.9. Okay.
Okay.
All right.
So
yes.
Sorry. So for investigation 5, we still work in group, right?
Yes. So try to communicate with each other to work in groups with that. So like any investigations that I give from now on, you could do it independently, or you can sort of communicate with each other via sort of, I don't know, FaceTime, or you can get your own Zoom account, although we're trying to kind of keep students from doing that so it doesn't overwhelm the system. But you can sort of work over Google Docs or over email if you have people that you like to work with in class. But those in the future will either be, you can work on it individually or in a group of 2 or 3 people. It's up to you. Okay.
Okay.
All right. So the schedule for this week looks like this. So before today, I asked to to fill this access to technology survey. And the link is here just to kind of give me an idea if there's anybody in the class who's having trouble sort of having a regular internet connection. And if you do, you might not actually be here right now, but if you do, there's a list of free or low cost internet providers. So if you can open this document, a lot of providers are often offering free or low cost internet over the next couple of months. So even if you have a regular kind of reliable internet, you might want to call them to get a free one. Anyway, and also there's a question at the end. It's like, what can I do to support you? So that's I read this and I'm going to take your suggestions. And I also asked you to watch the lecture notes for section 3.7 part 2. That was the part of the induction section that I didn't cover in class. And then the section 3.8 lecture. So those are basically the topics for today. Today, on Tuesday, we're going to do the live session. There's office hours after, if you want to hang around and still ask me questions. All right, and then before Thursday, you should watch section 3.9 and 4.1, right? And on Thursday, we're going to go over those sections. Quiz 6 is due in Canvas on Thursday by midnight, and the Pi Day challenge also. Right? And on Thursday, I'll make test 2 available in Canvas by 5 p.m. and you'll have 24 hours to complete it. It's going to be due in Canvas by 5 p.m. on Friday, right? So you'll have 24 hours to do test 2. The test 2 is open notes, but I'm going to ask you to not collaborate, so not work on it individually. Don't work together. Don't ask anybody else for help, including the internet. So it's sort of you and your paper in a very quiet room, all right? Okay, any questions so far?
How long, like, what sections does the test cover?
It's the last section in chapter 2, which was 2.5, the one with the combination of permutations with repetitions, okay? And 3.1 through 3.7. Okay, so,
Alrighty.
right, not 3.8 or 3.9. Okay, that will be on the next test. Okay. So basically, what we're doing today on Thursday is not going to be on the test. It's going to be on the next one. Okay.
And have you decided about the projects?
So yeah, I'm postponing them for now. So don't worry about projects yet. If we're not sort of coming back on campus, I think it's sort of impractical to get together with people and sort of play games and make videos. So I'm going to kind of rethink the projects. I'm thinking of just making one project that's going to be due at the end of the semester. It's going to be individual. So you basically will have the same amount of work that you would have if you did 2 projects with people. You just will do one project by yourself. Okay.
Okay.
But I'm putting the deadline for that towards the end, so you don't have to worry about it now. And hopefully we'll be back and maybe we can do stuff together.
Okay. And if the final is online, would we do that the same way as the rest of the tests?
Yeah, I think this is how we're going to test. Remotely is going to be, my intention is not to make the test any much harder than I would have in class. So they are open notes, so I want to kind of make them a little bit more challenging, more like the quiz problems that you've been seeing. But I don't want to make them like super tough. And I don't want to put like a short time limit on them. I was thinking of just maybe I'll open them for 2 hours, but I think that's really impractical because it's sort of, you guys have lives, right? I have my kids running around the house and making noise, and I'm sure you have sort of similar situations. And basically, I think it will be a challenge to try to kind of complete something under pressure in a couple of hours. So that's why I'm opening it for 24 hours. So you guys can find your own time when you can concentrate and you have quiet and you can go on time. Okay?
Okay.
All right. Any other questions so far?
Do we still get spring break next week since we
Yes.
didn't have class? Sick.
Yeah, you still get spring break. We're kind of going that week, the last week is sort of lost. I don't think they're gonna add anything at the end. I hope not. but sort of I'm going to cut out a couple of things, like, you know, a project, and I'm gonna maybe cut out a couple of sections. I'm gonna see how it goes towards the end. But I'm going to try to sort of squeeze in some sections and sort of complete as much of course as possible. So yeah, I think we're going to take that as a lost week. But yeah, spring break next week. So it's kind of good because we're experimenting, see how this works this week, and then as an instructor, next week I'm going to try to readjust and figure out if some things could go better. Like get better internet connection. That would be good. All right. Any other questions? Okay. So let me continue with. So let's keep looking at Canvas. Okay. So I made a new schedule this morning. So kind of if you look at the schedule tentatively, that's sort of how we're going to follow, but that might change, right? The link to get into the live session is always here. So whether I email it to you or not, it's sort of, I probably won't email it to you every time because I forget, but it's always here, okay? Just, I want to ask you to enter during like office hours or class time, because this is my personal link that's used for all my classes. So I do like on Tuesday, Thursday, I have classes from 9:30 to 5. Okay, so basically I might have half an hour in between, but if you enter before your class, then you're gonna be in the middle of my algebra class. So just gonna be mindful that I do have other classes to teach and they're in the same link, okay? All right, so quiz 6 is due Thursday. Quiz 7 is already available. So if you wanna start working on that, probably after the test or ahead, you can start working on that. That starts with section 3.8, okay? And oh, okay. I think, let me leave student view because I want to, oh, there it is. I just didn't reveal it. Okay. So that was invisible. Okay. So this is where you find test 2. Okay. I will probably email it to you also, but on Thursday at 5 o'clock, this test 2, if you open it, it will have a document there. Okay, right now it doesn't have a document, it's empty, but it will have a document there, and that will be your test. You can open it, start doing the problems, and by 5 o'clock on Friday, you should click on it and submit your work for test 2. Okay.
So we
Yes.
can write the test on paper and take a photo.
Mm-hmm. Yeah.
Yeah.
Yeah, so it's not an online test. It's not something that you're gonna do in like a My Math Lab or anything like that. It's just a paper test. You write all your work and then take pictures and submit the files. Okay. All right. Okay, so we're in the middle of chapter 3. Okay, so I pre-made some videos. Okay, so if you look through, starting from section 3. Yep. There we go. I'm back. It doesn't take too long. It only kicks me for like a few seconds. It's like, I don't like it right now. All right, so yeah, there's video lectures. And I made some, I'm trying to kind of get ahead. So there's 3, 7, 3, 8, 3, 9, and 4, 1, and 4, 2 already done. So if you are the kind of person who like to work ahead, they're there. Okay? So each of these links right here will contain video lessons in a few parts. Like the first one I made was like an hour and 15 minutes. So it's like, well, that's way too long to watch. So I broke it up into like 15 to 20 minutes increments. Okay, so I made lessons for all of section 3.7. So if you want to rewatch some of the induction stuff, even though I taught it in class, you can do that. So like the part 4 is where we're talking about strong induction, which we didn't cover in class. Okay, and then I also attach files of just the paper solutions. So basically I recorded myself as I wrote on the whiteboard on the computer, and I saved the pictures of the whiteboard, and the solutions are written there too. So that's what's available to you for each of the sections that we're gonna cover, okay? So these I want you guys to maybe like watch ahead of time. So you come in with sort of seeing the lecture already, and then we can go over stuff in class. All right, any questions on that? All right, so let's do some math now. So quiz 6. Okay, so anybody have questions from quiz 6 stuff? Let me get a whiteboard.
Yeah, can you go over number 14?
All right. I'll get my paper. Okay, let's see. So number 14, although I could probably work on here too. This is quiz 6. Quiz 6. 14. So 14 is, oh, this one. I like this one. Okay. So the number of strings of n zeros and ones that contain an even number of ones is 2 to the n minus 1. Prove this fact by induction for n is bigger than or equal to 1. Right, so let's see. Okay, so let's look at the basis step. Okay, so the basis step is the biggest, so the smallest value of n that you're interested in. So this is p at 1. Right? So n refers to how many bits you have in your string of ones and zeros. So n is 1, it means that you have a string of length 1 bit. Okay, so what are my options here? I could have a 1, or I could have a 0. Okay, so how many of these have an even number of ones?
1.
Well, so this one has an even number of ones. So this one has an odd number of ones, this one has an even number of ones. So one of the strings have an even number of ones. So that's that's the number. And then we want to show that this is equal to 2n minus 1. So if I plug in n is 1, I'm going to get 2 minus 1, which is 1. So it works for n is 1. It works for the basis step. Okay? Mm-hmm. Now the inductive step. The inductive step says that we're going to assume pk is true. So pk is true says that a string of length k has 2k minus 1 strings with an even number of ones. Okay, so that's for the kth case. We're basically assuming that this is true. Okay, and ignore this. And we're trying to prove that this is true for pk plus 1, that this formula works. So the pk plus 1 statement would be that a string of length k plus 1 will need to have 2k plus 1 minus 1. So it will need to have 2k strings with an even number of ones. So that's what we're trying to show, okay? So using PK, show that PK plus 1 is true. So let's kind of think of what's happening at PK. So we're going to have 2k minus 1 strings that have an even number of ones. Okay. How many strings will have an odd number of ones?
Same number, 2k minus 1.
The same number, 2k minus 1, yeah. So basically half of them, right? So in total, right, if I look in how many strings in total for k, so in total, a string of length k has 2k possible strings. So if you divide by 2, you get 2k minus 1. Half of them are going to be even, half of them are going to be odd. So why do I need to know this? Okay. So because if I have a string length of k plus 1, I'm adding one more digit to my string, okay? So in the case of the strings that already have an even number of ones, what should I add to it? What bit should I add to it to keep it having an even number of ones?
A 0?
A 0, right? So I have 1, 2, 3, 4, 5. I have k bits here. For my k plus 1 bit, I only have one choice. Okay, so here is only one choice because you're forced to write a 0 in there in order to keep it even number. Okay, so you have still 2k minus 1 choices that come from these strings. Does that make sense?
Yeah.
All right. Now, if I look at the strings that have an odd number of ones, again, I have my original string on there, and I want to add an extra one, right? What do I need to add as the extra bit to make it have an even number of ones?
A 1.
A 1, okay? Because that will make it even number of ones. But the important thing is that here you still only have one choice.
Mm-hmm.
So we're going to have 2k minus 1 strings that were made into even ones, okay? Now, both of these are even. So this, I have 2k minus 1 strings of length k plus 1 that have even number of ones from the original ones here. And then 2k minus 1 choices for these strings of length k plus 1 that were made even from the original odd ones. So if I add these together, 2k minus 1 plus 2k minus 1 gives me what? This is 2k minus 1s, which is going to be 2 to the k, right? And that's what I wanted to show. I wanted to show that there were 2 to the k strings with an even number of ones.
Okay, thank you.
Okay. All right, any questions with this problem? Any
So
clarification?
it looks like to me that you answered it with logic instead of a mathematical type of.
Well, it's an inductive proof because you're using the PK statement as true, and then you're transforming that into the PK plus 1 statement. So we're not doing algebra. Okay, so this one is kind of different than the others because all the others we're doing like we're substituting this and that, and we're multiplying things on each side of the equation. So I see what I mean, that is sort of more logical than algebraic. But yeah, sort of with induction for these kinds of problems, sort of the algebraic is not there because we're not proving a formula, we're proving things. So how many are there? So you're right. I think it's sort of more a logical argument rather than an algebraic one.
Yeah, I think that's what threw me off too, was I wasn't sure like what to do with the algebra.
Right, right. And strong induction, if you look at the videos, that's very much like that too. So the strong induction argument is not so much doing algebra and substituting things into each other. It's more this argument that it's like, because of this, you have that, because of this, you have that. So there's a lot more writing in some problems than math.
Would you say that on an exam it's probably better to show more reasoning like you have on the screen than less? And also, how do we know if it's a regular induction versus strong induction question?
Okay, I'll go over a couple of strong induction examples, and I'll talk about the difference between them. Right.
Okay, thank you.
But yeah, sort of, I don't know, it's sort of, yeah, I think showing reasoning is a good idea. All right, so I think for the like basic induction problems, the ones that were earlier, sorry, let me clear this.
And we do have induction on the test, right?
Yeah, so this section is on the test induction. Yeah, for this earlier ones, they were very algebraic because when you're showing that a formula is true and showing that an inequality is true, or showing that sort of something is a multiple or it's a divisibility problem, then it's more like an algebraic argument. And you don't really have to write many words as long as you're kind of showing the correct substitution. But if it's something like with strings or with sets, or if it's a strong induction thing, then it will require a bit more writing.
So for the more mathematical ones, we don't have to do like a whole basis step and induction step. We just have to do like algebra that shows that it's true.
No, you should, if it's an induction proof, you need to do the basis step and the inductive step. That's part of induction. So regardless of whether you're doing algebra or words, you should show basis and inductive step. Okay, Joyce, you had your hand raised up. Do you have a question?
Can you help me on question?
Sorry, you have a lot of feedback.
On the free question 1B.
1B?
Yes.
1B, okay. Let me actually, before I go there, I think it's a good time to talk about the strong induction because we're sort of in this area. All right, so the strong induction, so on the quiz 17 is a strong induction one. Okay, so let me go over a couple of examples from the lecture, and I'll kind of talk about how that works. All right. So the strong induction proof, you're still going to have a basis step. Again, you're trying to show that sort of the lowest possible case for n is true. But for the inductive step right here, you're not just assuming that the pk case is true in order to help you prove the pk plus 1 case. You're assuming that pk and everything lower than k, so all the statements up to pk are true, because often like just the pk step is not enough to help you prove the pk plus 1. So you need all of them that come before, okay? And this works for the same reason as the regular induction works, because this is hi again. All right. There we go. Let's go back to here. And of course, when it kicks me out, it kills all my annotations. So, okay, I'm not getting frustrated. All right, let's see. Okay, so let's look at this. So this is the basic. Let's look at this example. So show that if n is an integer greater than 1, then n can be written as a product of primes. All right, so let's do n is an integer greater than 1. So my basis case would be...
Hi.
Hi. My basis case would be P2, okay? So 2 is equal to 2 times 1, okay? So it's a product of the prime number with 1, which is not considered prime, but basically you can, that's allowable here. So 2 is a prime times 1. So you can say it's a product of primes. So it works for the basis case. All right. Now for the inductive case, okay, so you're going to assume that all the numbers up to and including k, so numbers 2, 3, 4, blah, 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 all the way up to k, all these numbers can be written as a product of primes. All right. So these are these propositions pk0 through pn. Okay, so all these are assumed to be true. And we need to show that k plus 1 is equal to a product of primes. Okay, so this one, regular induction is not enough, because if I just say that k can be written as a product of primes, it's not enough to show that k plus 1 is a product of primes. So what we're going to do here is going to say, we're going to break this into two cases. So case 1 is if k plus 1 is a prime number. Okay, so if k plus 1 is a prime number, then k plus 1 is going to be equal to k plus 1 times 1, and it's automatically a product of primes. So that's the simple case. We're done. Right? Case 2 is when k plus 1 is composite. Okay, if k plus 1 is composite, yes?
Sorry, what does composite mean?
That it's not prime.
Okay.
So a composite number is not a prime number. So if it's a composite number, that means I can write it as a product of two other numbers or two other integers. I can write it as L times M. Okay. So what's important here is that L and M are going to be less than or equal. They're going to be less than k plus 1. Okay. So if this is a composite number, if I break it up as a product of two integers, these two integers are less than the original number itself. Does that make sense? And if I have like 15, I can write them as 5 times 3. Okay, so it's possible, if it's composite, it's possible to write them as a product of two numbers other than the number itself. Okay, right. So yeah, this is kind of the important part of the problem here. Okay, because if I go back to this assumption, if L and M are less than k plus 1, what can I say about the number L and what can I say about the number M? What does this assumption say? So that assumption say that any number up to k plus 1 can be written as a product of primes. So L is a product of primes. And M is a product of primes. Okay? And because L is a product of primes and M is a product of primes, if I multiply these two numbers together, then this product is going to be a product of primes. So that means k plus 1 is a product of primes. Okay, and that's it. That's the end of our argument, because that's what we're trying to show. Okay, so this is basically the important step here. And I'm saying that a composite number can be written as a product of integers. There are less than the original number, and because of this assumption here, any number less than that k plus 1 is a product of primes multiplied together. That's also going to be a product of primes. So strong induction, very wordy, not so much equations, not so much algebra, but this argument, this logical argument.
And that'll be super similar to number 17, except we're doing it with sums.
Yeah. So yeah, this is very similar to that number 17. Okay. And very similar to like example 11 in the notes. So again, this is in the lecture video. But yeah, you look at, this is sums, like 12 cents can be written as a sum of 4-cent and 5-cent pieces. So that's like a sum argument there, but it's very similar to this product one. Right, any questions with this one?
Yeah, in the first case, when k plus 1 is a prime,
yeah,
is it possible because 1 is not a prime number?
Yeah, so this is okay. This counts as a product of primes. Okay, so because it's we're saying that this k plus 1 is prime.
Mm-hmm.
So prime times 1 is it counts as it being a product of primes.
Okay.
Is the assumption that all the numbers leading up to k included or like true just for this problem, or is that like a thing for strong induction in general?
That's the strong induction argument.
Okay.
So this is number 2 here. This says for all of n bigger than k0, all of the propositions up to n or up to k are true. And that leads us to prove that the k plus 1 or the n plus 1 is true. So yeah, this is the strong induction argument. So it's not just this problem.
So for example, 11, M and L isn't greater than 12?
Yes, so for 11.
But does that make P13 cannot be inducted to be proved?
Yeah, so let's see. So for 11, we have every amount of postage 12 cents or more. So our basis step starts at 12, okay? Mm-hmm. And that's saying that something that's 12 cents, can I write it as a sum of only 4 and 5s? And you go, yes, because I can write it as 3 4s. Okay, so that works. The inductive step, we're saying that everything 12 and 13 and 14 and 15 all the way to k cents, this is true. Okay, so this we're assuming that these can be written, assume these can be written as a sum of only 4s and 5s. Okay, so that's kind of the induction bit, that this is like k0 and that's k1 all the way to k. We're assuming that those can all be written only as in 4s and 5s. Okay, and then what we're trying to show is, can I write k plus 1 as the sum of only 4s and 5s? Okay, so just like before, it's like if I have a number k plus 1, say I have the number 25, I can write it as the sum of 2 integers that are smaller than 25. Okay, so I could write 25 as 12 plus 17, or I can write it as 11 plus 14. So I can do arithmetic. So I can sort of take this number and break it up into the sum of 2 smaller ones. Right, so that's kind of the key here.
I guess my question is, like, if k plus 1 is 13, then 13 can only be made of 12 plus 1, right? But then 1 does not suit for this situation. So
yeah, so I think,
It's
okay, so I think like 13. Maybe we,
Oh,
yeah,
13.
13
4,
can be
4,
done
5.
differently, right? If 13 can be done 4 and 4 and 5, okay? So it's kind of like you can still base this on 12 because 12 is 4 and 4 and 4. You're saying for 13, I'm gonna take 12, but change this 4 into a 5 because you're adding 1 extra to it. So you can transform the 12 into 13, and that
but
will.
this will not be like the same logical proof we just made, right?
Oh, I see what you mean. Okay, so
does that mean like from 13 to 13 plus 12, then
so for 12, like 13, it kind of looks different because we're like changing a 4 into a 5. How about 14? So 14. So 14 is 4 and 5 and 5, right? Okay. But basically at some, and 15 is 5 and 5 and 5. Okay. But then if we get to 16, we're back with the 4s. They're all 4s again. Okay. So we could say that, like, if the number is less than 16, then we can sort of, you could say that these are the basis cases because they're all like slightly different.
Okay.
You can have like 4 basis cases, but once you hit 16, then it's a repetition. Okay.
So it's like basis case can be more than 1.
Yeah. Yeah, you can. If it's sort of, if it kind of doesn't fit in exactly the same argument, you're kind of looking at this in a lot more detail, which is great. But yeah, if you sort of doesn't fit exactly the same argument, then you can sort of, yeah, these are kind of slightly different. So you can kind of all consider all those as basis cases. But once you get to 16, you can use the others. Okay. All right. So to continue this, so yeah, kind of say that maybe we're looking at 16 and over, then this argument would work a lot better. So if k is bigger than or equal to 16, okay? Then you're saying k plus 1 can be written as the sum of 2 smaller numbers. But according to this assumption here, because they're smaller than k plus 1, this can be written as a sum of 4s and 5s. And this can be written as the sum of 4s and 5s. Okay, and because they can both be written as a sum of 4s and 5s, if you add them up, the whole sum is made up just out of 4s and 5s. Okay, so that's the end of it. That's the strong induction here. Okay, any questions on that one? All right, so this is number 60, the number 17 on the quiz. Okay. Let me fill out my quiz. Clear this. Yeah, so that's the postage. You can make a postage of 8 cents using only 3 and 5 cent stamps. All right. Hello, I'm back. All right, so let's look at, I think there was, Joyce asked me for
1B.
1B. Okay. So 1B, see if I can do the annotation on here. There we go. There's my pen. Oh, there you go. So 1b. So this gives you a bunch of conditionals. So if P then Q, and if R then S, and then comma, if Q then T, and if S then U, and negation, another conditional, and you're supposed to show not P. Now, we kind of talked about this. Commas and ands mean the same thing. They're the conjunctive thing. So if it's an and between, you can put a comma in here. Or if it's a comma in between, you could put an and between them. So they're interchangeable. So you can break them up into individual ones, right? You disconnect them because it's like, it's this, right? If it's a conjunction, then this implies P, or if it's a conjunction, then it's going to imply Q with the conjunctive simplification. So if they originally were and in here, you can disconnect them, okay? All right, so I'm going to do the direct proof. The indirect proof, you can also do it. It's always valid to do the direct proof and then add another line at the end to put the not P, the sort of the negation there to show that it's a contradiction. Although it's nice to come with the indirect proof that doesn't follow the same steps, just to have it, kind of the intent of the indirect proof is to make it shorter, to make the proof shorter. But if you do the steps of the direct proof and put the negation of the conclusion at the end, that's also valid. All right, so I think this one is long because it has like so many of them. So let's see. Oh, I hope I won't get lost. So let's start with this one just because it's different. So we're gonna say not T and U. This is going to turn into not T or not U by De Morgan. Okay. All right, let's see what I can do with it. So my goal is to, there's like so many of them, like all of them are conditionals. And what I'm trying to get at the end is a not P. Okay, so my goal is to probably get a conditional that looks like this. It's like connecting either P's together or not P's together. So I'm gonna try to do a bunch of chain rules to get my P's on both sides, because this will transform into a disjunction or that will simplify into that. Okay, so I have a U here. I think I need to connect it with something else that has a U. So the only one that has a U is this one. Okay, so I'm going to turn this around. I'm going to use the contrapositive. Oh, no, I'm going to turn it into a conditional first. So I'm going to say not T or not U is the same as T then not U. That's the conditional. And then I'm going to use the contrapositive to make it U and therefore not T. So this is contrapositive. Right? So the reason I did that is so I can connect it with this. Okay, so I'm going to say S then U and not T, because one ends in U, one starts with U. This is going to be S then not T. That's the chain rule. Gotcha. Are we good so far? Yes, I've used this, I've used that. Okay, so I see that this has S and T in it. So I'm gonna see if I can, here's one with the S at the end. So I'm gonna connect it, so R then S, S then not T. This is gonna turn into R then not T by the chain rule. Okay. All right, now I have R and not T. So let's try to put it with this one. Okay, so because the T is at the end and this has a T at the end, I'm going to use the contrapositive to switch the order. So this is going to be T and not R with the contrapositive. And then I'm going to take this one with this one with this one. So I'm going to take Q then T and T then not R. and that's going to give me Q, then not R with the chain rule. Chain. Right. So the only one now I haven't used this one, and it's good. It ends in Q. Okay, so number 8 is going to be P then Q, and Q and not R. This is going to give me P and not R. So that's the chain. Okay, I'm almost there. This is the only one I haven't used yet. Okay, so I'm going to do the counterpositive on this. So I'm going to have R and not P, the counterpositive. And then I'm going to connect these together. So I'm going to have P and R and not P gives me P, therefore not P. So that's the chain rule again. Okay, I think this one. Okay. All right, so this I can change into a or. So this will turn into not P or not P with the conditional equivalence. Okay. Conditional equivalence. All right, and number 12 is going to be if I have a proposition or proposition itself, then this is the idempotent law. Okay, that says like if I have P or P, this implies P. So that's the independent law. So if I have not P or not P, that's going to imply not P. So that's the conclusion right there. All right, so again, could be other ways to do it, but that's how I flow of consciousness here. That's how I got to the end. All right. Any questions? Okay.
So we can always do the same thing for the indirect proof and just do the not and the statement that we're trying to get to.
Yeah. So basically sort of the, should I call it the lazy ways of doing indirect? Because the indirect, you're going to have to negate the conclusion and add it to the premises. So this will become a premise. So if you do exactly the same steps as you did for the direct, then at the end, you're going to have a contradiction. Okay? So that's the indirect proof. So you can definitely do it that way. This is perfectly logically valid to do it. It would be nice to try it negated and sort of try to work backwards like a different way, because the purpose of the indirect proof is that you cut down on the number of steps. Okay. But I'm going to accept an indirect proof as doing this at the end. That's fine, because it's not invalid. So I can mark you off because they're all valid steps.
What does idempotent mean?
This is the idempotent law. So yeah, so it's in the laws of logic. It's in the top table. I think it's towards the bottom. It was all with the commutative and the associative and the null and identity, and one of the laws is called the idempotent law, and that's this one.
So, Professor, if we were to use conjunctive simplification or disjunctive simplification, would we have to use both?
No, they're different, and it depends what you have, right? Mm-hmm. So the conjunctive simplification, if they're connected with the and, then you can separate them. You can use them each separately. But the disjunctive simplification, if you have P or R, you can't separate them unless you have, if you say P or R and not R. So you know, if you have either of this or that, but you know that you don't have one of them, then that's going to simplify to P. So it doesn't really matter in terms of you have to know that one of them is not. You have to have the negation of one of them. Okay.
When there are multiple chain rules, can we combine them into like one step, or would you prefer them to be indifferent?
Yeah, you can combine in one step. It's
Okay.
sort of the more you can cut down on the laws, the better. So yeah, if you had S and U and U and not T and not T and something else, yeah, you can smush them into one. That's all
Okay.
valid too. It's like the chain rule in calculus. You can sort of do everything at once if you can. All right. Any other questions? Let me check my
Could you do number 7?
number 7. I will look at number 7. Oh yeah, you asked me about that before. All right, let's see. Let me clear this and look at number 7. Oh, I don't know. Doing this one will just sort of give you the answer. There's a couple of ways to do it. I know kind of the answer in the book. So did you come up with any ideas? So we have S as a proposition over this universe, and the truth set is that. So it kind of says give examples of two propositions, which will make that the truth set. So anybody come up with the first example?
Is it valid to just say you want all the odd ones from this universe?
Yeah, that's fine. That's the easy one. Yeah. So yeah, if you just say that, take the odd numbers from the universe.
And then would it be the same thing just to write 2n minus 1? Or do you want?
That is
Okay.
the same thing, yeah. So if you write odds or 2n minus 1, then that is the same thing. So they would both count for odd.
So can I say n is not even?
That's also odd. And it's not even. Yeah, that's a good one. I think the answer in the book gave something like, all of these are the solution to the equation s minus 1, s minus 3, s minus 5, s minus 7 equals 0, right? So I think that's the solutions to this equation. Okay. I want you to come up with something. I mean, that's certainly fine. I was playing around with it, and I'm kind of proud of myself because I came up with something that used the ceiling function. Like, the ceiling function is this rounds an integer to the next higher integer. So like if you have something like 1.5, it will round up to 2. Or if you have something like with 2, it rounds it up to 2. Or if you have something like 1.1, it rounds it up to 2. So it rounds the number up to the next highest integer. So I worked something out with using the ceiling function to kind of give me that truth set using those as inputs. So these are your inputs, and you basically want a formula to give you that as outputs. So I don't want to give that answer because I like you guys to kind of think about it and be a bit creative. The odd numbers or the not evens are sort of the kind of easy answer, but the second option, it would be nice for guys to play around with it a little bit.
Can you also write down, for example, 2n plus 1, and then restrict the n numbers to be like 0, 1, 2, and 3?
No, because your n numbers are given here. Your n numbers are already restricted. So this is what this is. This is the universe of n values. So it has to start at 1 and end at 8. So that's why 2n minus 1 works, but 2n plus 1 doesn't.
But I guess my question with that one is, if I plug in 8 in for n, I have 2 times 8, which is 16 minus 1.
Oh, okay, so that doesn't work. So what would work here? What would make this? Do I have to? Oh, so this formula doesn't work, does it? I have to do something like divide by 2. Ooh, I think that's where my greatest integer function came in. Yeah, because I was basically using, I think that's what I was trying to do, like 2n minus 1, and the biggest one was 16 or 15. And it's like, oh, I have to divide it by 1/2. But if I divide by 1/2, I'm going to get decimals. So then I use the greatest integer function, so I wouldn't get decimals. So I kind of combine this with the greatest integer function to get these values.
Okay, so we do have to use something that, allows us to use all the n values in the universe.
Yeah, I would say so.
Okay.
Does it? Well, I would say you don't have to use all of them, but you can't use values that are not in the universe. This is a proposition over. Yeah, I don't think you have to use all the numbers in the universe. It's like if you have a function, right? The domain is all the real numbers. Do you have to use all the real numbers in the function to? Yeah, you do, because that's the definition of a function. Maybe a function is not a good example. But yeah, it's not clear whether you have to use all the values in the universe. It's like with sets. You're given a universe and you don't have to use all the values to have a subset of it. So I guess I'm not clarifying this much, but I don't think you have to use all the numbers in the universe. I did, but I don't think you have to.
Could you also say the sum of consecutive integers so long as it doesn't go higher than 8?
Oh, yeah, I guess you could put a limit. Like, I think that would be in the same sort of vein as the last questions. You can stop it. You can say that yes is going to be the sum of consecutive integers as long as the input is less than this. Okay, so you're going to use some values of the universe to get that true set. Okay, I think that's a good approach. All right. Okay, anything else from quiz 6? Yeah, it was true sets and the laws of logic and induction. Good, we went over strong induction, so we can finish that off. All right, so let's look a little bit at, so kind of this is what's going to be on test 2. Okay, so let me go a little bit over what's in section 3.8. Okay, so obviously not a full lecture, just kind of an overview. And sort of, again, my expectation is that you're going to pre-watch the videos, and when you come in, you should have clarification questions for me, okay? So I'll kind of go over, and if you have questions about stuff, stop me, and if you don't, I'll pick a couple of examples in here. We have about 15 more minutes in class left. I'll pick a couple of examples that I think are a little bit harder. So section 3.8 is on quantifiers. So basically quantifiers allows us to look at like propositions over universes, right? And make like logical statements with proposition over universes. So we have these quantifiers. These are the two main ones. The existential quantifier and the universal quantifier. So the existential quantifier is like there exists a value of n in the universe for which this proposition is true. Right? Often the universe is dropped. Right? So this means that one or some values in the universe makes that proposition true. So as long as sort of the truth set is not the null, you have at least one value that makes the proposition true, then that's kind of how you say. And the universal quantifier is this inverted A. The universal quantifier says that the proposition is true for all values in the universe. So this basically describes a tautology. So, so when you see a statement like this, proposition is true for all values of n. So it's this is called the universal quantifier. All right. So we kind of want to look at for when these are true or false. Okay, so the universal quantifier, the proposition is true for every value of n in the universe. And it's false if you can find a counterexample. It's false if you can find just one value of n for which the proposition is false. And then for the existential quantifier, the existential quantifier is true if you find just one value of n in the universe for which the proposition is true. This is going to be false if the proposition is false for every single n in the universe. Okay, so you can kind of see they're a bit opposites of each other. So the universal quantifier is the equivalent, it's a generalized conjunction and statement. It's like the proposition is going to be true for n1, and n2, and n3, and n4, all the n's in the universes. And the existential quantifier is a generalized or statement. The proposition has to be true for this n, or that n, or that n, but not for all of them. Okay, so you can kind of think of them that way. All right, so let's see. These are sort of the easier example. Okay, yeah, let me look at example 5. So example 5 says, what is the truth value of this statement if the domain consists of all real numbers? Okay, and then we're going to look at if the domain consists of the integers. So this statement says that there exists a value of x such that x squared is bigger than x. Okay, so if I have my domain or the universe being the real numbers, let's see if this statement is true or not. All right. And I'm going to say this is true, okay, because I can find at least one value of x in the reals for which this is true. Right. For example, if x equals 2, 4 is bigger than or equal to 2. Okay, so because it's existential, it only has to be true for one value for it to be valid, for this to be true. Right. If it's the integers, right, it's also going to be true. And this same example works too, because x is an integer here. Again, I can find one integer value for which that is true. Okay, so this is done. All right, what about if I look at the universal statement? Okay, over the reals. Is this still true if I'm looking at the real numbers? So is that going to hold true for all real numbers x, or can I find a counterexample? What do you think?
It's
I think you could
1
find a
over.
counterexample.
Yeah.
Right. So if x is 1 over anything, right? So 1 over 2, for example. So yeah, if I have a fraction, so between 0 and 1, then if I square it, this is not going to be bigger than the number itself. So because I can find at least one value for which it doesn't work, this is going to be false. Right? How about over the integers?
It's true.
Yeah, this is going to be true over the integers, because the only values where this doesn't work is fractions between, right? If I have x is between 0 and 1, this statement is not going to work. But there's no integers between 0 and 1, so this is going to be true for all integers. If they're positive, if they're negative, it's going to work for both. All right. So this is a good example to kind of distinguish between the existential and the universal statements. Kind of for existential, it only has to work for one value. Universal has to work for all values for it to be true. All right. Okay, so yeah, if you look at quiz 7, then a lot of the problems will be looking at truth values and also translating. It's like, what does this statement mean? So let's see. All right, let's look at some negation. So if we negate quantifiers, then because these are like generalized conjunction and disjunctions, when you negate the universal statement, this is De Morgan's law. This is a general De Morgan's law. So if I negate ands, right, this is a bunch of like Pn1 and Pn2 and so on, then it's going to become a or. Okay, so the negation for a universal statement kind of distributes to the proposition, and every time the negation passes through the universal quantifier is going to become the existential quantifier, and the negative goes in front of the proposition. Right? Same for negating an existential. In order to distribute the negation to the proposition, the existential is going to become the universal. So again, these are generalized De Morgan's laws here. Okay, so when you distribute a negative, and becomes or, and ors becomes ends. So the universal becomes an existential, and existential becomes a universal. Okay, so let's look at a couple of negation. So what are the negation of the statement, there is an honest politician? Okay, so let's actually translate this into symbols. So there is an honest politician, we're going to be, there exists a politician who is honest. Okay, so X is like in the universe of all politicians, and H is that a person is honest. Okay, so if I negate this, this is going to turn into what? So negating the existential turns into a universal, and then the negation goes to the proposition. Okay, so what does this read? This says
there is no exception that all politicians are dishonest.
It's like there are. So this says all politicians are not honest. Yeah, so all politicians are dishonest. Okay, so the negation of there is an honest politician is all politicians are dishonest. Okay, does that make sense?
Is that the same as there is no honest politician?
Yes. Yeah, so there is no honest politician. It's the same as saying all politicians are dishonest. Okay. All right. So there's a similar thing with the Americans and the cheeseburgers. Okay, let's see. Now let's look at negating like a mathematical statement. So if I negate these, right, so basically when you have negations, you want to distribute the negation to the proposition so you can work with it. So if I negate this, so this says that for all x, x squared is bigger than x. And this is true if x is an integer, right? We saw that before. All right, so if I negate this, then this is going to be there exists a value of x for which this is not true. So you can say that there exists an x for which x squared is less than or equal to x. And we saw that this is the case if x is a real number. Okay, so the negation of this is going to be that. All right. If I want to negate this one, so if I have there exists an x for which x squared equals to 2, I want to do the negation of this. That will say that for all x, it's not true that x equals to 2. So for all x, then x squared is not equal to 2. Okay? And again, that would be true if you're considering x to be like an integer or to be like a rational number. So, but the negating the existential will turn it into a universal of the negation of the proposition. All right. Any questions with those? No. All right. Let's look at a couple more things. Oh yeah, I want to go over these. I guess look at those can be a little. So when we're translating statements with these quantifiers, it depends what the universe is. So if you change the universe to be like a bigger group of people, you need to readjust your translation to sort of include sort of more propositions. So we'll see. So part A said, every student in this class has studied calculus. Take the universe to be all students in this class. So we take X is a student in this class. Okay, and let's say that C of X is that a student has taken calculus. Okay. So every student in this class has studied calculus. Every student is like all X, where X is a student in this class, has taken calculus. That statement is true. Okay, so all students in this class have taken calculus. That's the translation there. Okay. Now, if I take the universe to be all people, so X is a person, then I really need two statements, two propositions, because I need to have that the person is in our class. It's in the discrete math class. So person is in our class. And I also need the statement that the person has taken calculus. All right. So now every student in this class has studied calculus. I'm going to have every student. So this doesn't say every student. This says every person in the world. Right. And then I have to basically specify somehow that they're in our class and has taken calculus, right? So the way I say that is that if that person is in our class, then they have taken calculus. So it's a conditional like this. So for all people in the world, if they are in our discrete math class, then they have studied calculus. So changing the universe to a wider group of people, you need to change your proposition to specify that you are only considering people in our discrete math class, and if they are there, then you say that I have taken calculus. All right, any questions with that one? All right. Cool. All right, so again, okay, the intent for the live session is not really go through the lecture because they're already pre-recorded, but it's to sort of clarify things. So I kind of want you to listen to and take notes, and then when we meet, we can get over quiz problems, but we also can go over the examples that were confusing from the lesson. Okay, so we're gonna end now. Okay, so the next time we meet, I'm going to take questions from quiz 7, which is already up there. So quiz 7 starts with section 3.8, and it's also 3.9 and 4.1. So it has those 3 sections in it, which will be tested on the next test after the break. But yeah, kind of come back to class on Thursday, and we can work on those kinds of problems. All right. So let's see. In the meantime, finish quiz 6. That's going to be due on Thursday night. Okay, obviously I'm going to take questions from that too. And yeah, right, and it's going to be uploaded there. And I want investigation 4 and 5 to be uploaded in Canvas by tonight. Okay, and I'm working on grading your writing assignment 6. I haven't forgotten about them.
So,
Yeah.
sorry, if we turned in investigation 4 in paper, do you still want us to turn it in on Canvas?
No, if you turned it in and if you already have a grade in Canvas, that means that I have it and I graded it. I graded all the paper stuff I have.
Okay, and then investigation 5, we were working on it together. We finished most of it in class.
Yeah.
So does one person just need to submit that, or do we each?
Yeah, that's fine. As long as you just clearly you put somewhere the names of the group members, then if you just one of you submit it, then I'll give the grade for everybody.
Okay, thanks.
All right, any other questions?
Yeah, on mine I have a grade, but there's a tag on the status that says missing.
If you have a grade, that's fine. It counts it. I'm not sure. Oh, okay. It's the way Canvas works. Like if it's an online submission and you personally haven't submitted the file, then it shows it as missing because like your group member probably submitted the file. But I put the grade in already because I saw your name was on somebody else's paper. So ignore the missing thing. Because you have the grade in there, it counts it.
Okay.
All right, so we're in office hour time. Please feel free to hang around. I'll stay until 5:30 and answer more like individual or small group questions. I'm happy to hang around for a bit. All right, otherwise, bye. I hope this is useful to you guys. The meeting was recorded. I will upload the recording to Canvas, probably just underneath the Zoom link, so you can look back at it and yeah, if it's needed. You guys are watching a lot of videos. All right, that's it. Bye, guys.
For future investigations, can we continue to do them in groups, or would you prefer for us to do them individually?
You can do them in groups. Like I'm happy for you guys to work in groups of 2 or 3 people. So, but if it's hard for you to connect with people, then individual submissions are fine too.
Also, is there any like phrases or words in a problem that would signify that you're supposed to use induction or strong induction?
Not really. I guess it's kind of remembering what type of problem. So it's kind of like the regular inductions, like proving a formula or inequality or divisibility or other things. Strong inductions were things like the product of primes or the sum. If I give you this on a test, I'm going to specify which one to use.
Okay, thank you.
That's very much based on experience of, I've done 100 of these problems. I know this works with strong induction, but you guys haven't done 100 of those problems. So I'll specify use induction or strong induction.
Okay.
Okay.
And for questions 8 to 12, even though it says like prove this like equation or something, we don't have to use induction to do that. We could just...
No, those are induction problems.
Questions 8 through 12? Oh, what?
Is that quiz 6? 9. I think 9 is the first one. Yeah, these are all induction problems. It doesn't say use induction, but yeah, those 9 through 17 are induction problems. And I think that 17 is the only strong induction ones.
Okay.
Okay.
Thank you.
So yeah, please use inductive basis and inductive. Okay.
I think some are curious about the quiz number 3.
Okay. Quiz 3?
No, quiz 6, number 3. Question number 3.
Oh, question number 3. Oh, okay. So what's your question about that one?
Yeah, I think somebody asked in the discussion that how can we determine the validity without working out a truth table?
You can do it the laws of logic. So after you translate it, you don't need to do the truth table. You can use you can prove it like we did number 1. All those is number 1. Okay, and same for number 2. Okay, so right, number 2 also. These you don't need truth tables for these. You can do it the logic laws. All right, so how did you translate number 3? Did you get the translation for it? Does like anybody have a translation for number 3? So for students to do well in a discrete math course, it is necessary that they study hard. Okay, so that necessary right here means that that's the Q statement. So if it says necessary, whatever the necessary is attached to, that's the second part of the if then. So if I say this P, if P then Q. If P is do well in discrete math, and Q is they study hard. Now, students who do well in courses, this is different than students who do well in discrete math. These are 2 separate statements. I'm going to call that R. Do not skip classes. So if students do well in courses, then they do not skip classes. All right, students who study hard do well in courses. Was that the R? Okay, so these are my premises. Therefore, students who do well in discrete math do not skip classes. All right, so that's my translation. Okay, so PQRS, I would not do a truth table on this because we have 16 rows. It's just too big. But these are just like the laws of logic ones. So PQ, comma, R not S, comma, Q then R, then you should show this. So this is a couple of chain rules, right? So I can connect P then Q with Q then R to get P then R, and then P then R with R and not S, and that will get you to the conclusion.
So for for conjunctive simplification, if we have P or Q, we can apply P, right?
P or Q, the disjunctive, this does not imply P. P and Q implies P.
P and Q.
But P or Q does not imply P.
Okay.
Okay. Yeah, with disjunctive, if you have P or Q, you also need to know that not Q is true, and then that's going to imply P. That's the disjunctive simplification.
Yeah. Oh, yeah.
I keep forgetting to read my chats. Let's see. All right. If P, then Q. If not R, then P. All right. All right. Yeah, sorry, Justin. I wasn't seeing your chat. It's covered by everybody's faces. I have a small laptop. I might need to get a bigger computer. 2 screens, 3. That would be good.
Is it possible to submit our investigation for comments? Like, because I can't really share my screen unless I like flip it and kind of show it. But is it possible to do that?
You can't share your screen?
Well, I'm using my work computer to zoom in, and then I've been kind of using my Surface for notes.
Oh, okay. You can. Okay, so if I don't know if you can see my chat thing. If you look at the chat thing, there's a little file here.
Mm-hmm.
All right, and you can submit. Oh, okay. You're using. Can you like no? Sorry.
Actually, I might be able to, because here, let me try this.
Yeah. So if you can attach a file to the chat, then I can open it. I can see it that way.
Okay. Yeah, let me, because I just saved
email. Yeah, you can send it to me my email, and then I can open up my email. That's a good suggestion too, Justin. I think you're a problem solver. I can see that.
Let's see here. I'm just waiting.
Oh yes, or send it through Canvas. Canvas. Yeah, if you send an email through Canvas, that works too. I get it.
Okay, let's see if I could. I don't know if I'm doing this correctly, but maybe I could share. Oh, it says you cannot start screen share while other participants.
Oh,
share.
okay. I'm gonna stop sharing. Okay, try now. There we go.
Is something like that.
Okay, so find a strategy that guarantees your team to win. Okay, so you have force the second player into a multiple of 3. And if you must go first, don't go first. All right, so I might need a bit more detail. So why am I forcing the first player to be a multiple of 3? How are you actually gonna win if it's a multiple of 3? Right.
So. Oh, I wait, am I actually speaking here?
Yeah.
Oh, okay.
So yeah, you can kind of go into kind of the strategy. Like if it's a multiple of 3, it's like if he takes this, then I take that. If he takes this, then I take that.
Yeah, I kind of wrote it down here.
Oh, you wrote it here?
Yeah.
Oh, I see. Oh, right. So you kind of you specified the detail there. Okay, so I didn't read that. So yeah, if you have the different ends. Okay, so 4, take 1, right, 6. All right, so I see that you're doing that. So if you have the multiples of 6, then you're if you take 1, then they take 2. If you take 2, then they take 1. Okay, so yeah, I think that's detailed enough because you looked at all the cases in number 2.
Yeah, and I kind of went into up to 12, and then the pattern starts to repeat. Trying to see if I was supposed to develop the mathematical formula.
No, I think this is enough for now. So it's like in the project. All right. So basically that's for the investigation. This is sufficient. Just kind of a general pattern. For the project, I've had you guys look at the formula and then prove that it works with induction. So that's more detail that you need to do in the project if you choose to do this problem for the project.
Oh, okay. All right. So I'll probably.
Yeah, you can submit it as is, and it looks good.
Okay. Stop share.
Yeah, stop share. Awesome.
Has there been any news of possibly opening up the campus?
No, it's as long as the governor has us in, stay at home kind of thing, we can't really do classes at the college.
Yeah, I'm sure.
Yeah, it has to change from the state and other things like that. Like right now, it's yeah, I don't know. It's very unsure. I mean, they're not even testing for cases yet at a regular basis, so we don't really know how many people are sick. So it's really hard to predict what's going to happen in the next month, 2 months, 3 months.
Yeah, this situation's gotten pretty stressful. I'm sure you're in a similar situation where you with your children, but we're trying to keep up with our daughter's education, and my wife and I still have to actually go to work. We got excluded from the stay at home in place, so we're still. I had to report to. It's the sheriff's building, the new building that they had, and they're the it's becoming the media center for COVID-19. So it's like, oh boy, why am I going there?
Oh wow, yeah, I know. It's that I have 3 kids. My oldest is very self-sufficient. She actually got herself an internship at the food bank, so so she's helping out distribute food. So she's essential personnel. But my 14-year-old and my 10-year-old are at home, so I'm trying to do their education at the same time as I'm trying to do this. So I told them it's like Tuesday and Thursday are your weekend because I'm working from 9:30 to 5:30 nonstop. So, but then the other days I have like a lighter schedule, so we're doing lessons. But they're like, we're on spring break, and I'm like, yes, you are, but you have to learn. So yeah, I know it's a bit kind of working full time and homeschooling them at the same time. It's not easy. So I hope it doesn't continue too long.
It's well, it is. I mean, the shelter in place is kind of needed. My sister actually just got placed on isolation because she works at a healthcare facility, and one of the patients she came in contact with got diagnosed with COVID-19 last night.
Wow.
So she's forced into a 14-day.
Oh, the isolation. Okay.
And it started last night, and we're like, well, does that mean everybody in our household needs to stay in quarantine? And they haven't quite made that up. And
yeah, right.
We're like, well, are they going to send you a test and to know? And they're just kind of waiting for symptoms to show up. And I'm like,
so they haven't really tested.
No, because they're saving all the tests for people that are showing symptoms. So
right.
So she's super anxious, and she's
yeah, I can see that. It's like I can't believe that they haven't made tests available, because that's really, I mean, that's how China did it, that they were testing everybody and they figure out where the infections were and isolated the people who needed to be isolated. So it's they need to distribute tests to everybody. But anyway, I'm trying not to. My political opinions are very strong, so I'm not gonna bring them over to class. But yeah, so I think it's very stressful on people if they don't know who has it, who doesn't. I think it would be good if they did. So, but yeah, in terms of class, I think we're gonna need to continue doing this until we get the clear, and we might have to finish the class this way, and hopefully we can make it work. I think we can. How'd you guys feel today? You think it's workable?
I think it's workable, but it's certainly hard to stay focused. Well, I can't speak for everybody else, but at least in my particular situation, we're trying to make sure that I got 5 people in my household. Trying to make sure we keep our jobs. So at least in the back of my mind, if I had to decide between work and school, right now I'm kind of leaning towards, well, I better keep my job.
Yeah, I know what you mean. Yeah, definitely. So yeah, keep that withdrawal deadline in mind, because if it comes to that, I'm not sure I'm reading the news of what they're deciding with the withdrawals. I don't think they sort of decided
right
now to change the day or not. I don't think they have. So yeah, sort of in terms of I know kind of stress and pressure to kind of family and work, but hopefully I can sort of you guys can get the information and complete your assignments and do the test and stuff like that. That it's kind of not too much different than if it was face to face. But yeah, the personal factors and the job factors you'll have to consider at some point, definitely.
Yeah. Family's been helping out. They're keeping the kids at bay right now. So, this is one of the reasons why I'm using a headset, just so we could kind of isolate.
You can concentrate,
yeah. Because I don't know if the mic's picking it up, but I could hear it. And Frozen and all the Disney movies has been playing nonstop to the point where it's starting to get annoying.
I know my son is on Netflix right now, and it's just like, I know my dog is barking, I'm lecturing, and the trash pickup is happening outside my window, and it's just like I can't mute it. So I know what you mean. I know it just sort of we might get used to the distractions. We'll see.
Yeah. Well, I think I'll get to it then. So I'll leave you guys. Thanks for class today. See you.
Okay,
everybody.
no problem. All right, bye.
Professor,
Mm-hmm.
I was wondering if next time you could go over question number 13 in 3.8.
Okay.
The lecture video. I know you went over it, but I think I just got really lost in that one. So maybe a second explanation of that would be really helpful for me.
All right. Do you have time now?
I do. I just wasn't sure if maybe it would be a question that a lot of other folks had too.
Actually, that's a good idea. I think that we can keep it in class. And I see a comment from Justin that it's workable, but lecture being ahead of time and having conference during normal time takes hours away from homework. I don't know, would it be better to just have a regular lecture during this time and sort of keep it similar format? I mean, I could pre-record the lectures, and whoever can watch them on your own, you can, or I could sort of just do regular lecture during our meeting times. I don't mind doing that. Maybe I can poll people and see who prefers what, because I don't want to get you guys to work more than you were before. I don't want to waste your times, but since I kind of don't see you face to face, it's nice to be able to get people to ask me questions live.
I don't know. Thank you for putting up all the videos. I thought they were super helpful, and I'm impressed you did so many in advance. So thank you for that.
All right. Okay, we'll see how it works. We'll kind of keep doing this for a couple of weeks and see how it works. And if we need to adjust, we can make some adjustments.
Yeah, and I think whatever's easier for you too. We don't want to make you work overtime either.
I'm already sorry. I know it's inevitable, but it gives me something to do because I can't really do the things that I like to do with my kids. It's like during spring break, I like to take them places, and not happening. Maybe an occasional like trip to the park, but otherwise we can't really go many places. All right. Anyway, if you guys have more math questions, let me know. Otherwise, So Justin, I think that's fine. Like if you are getting enough information from the pre-recorded, and you can sort of work through the homework, then I'm not taking attendance for the 3:30 to 5 meetings. So if you don't think that it's sort of you need to come, then that's okay with me. If actually, yeah, if you're not getting anything out of it, then it's like, what's the point? So some people are more independent than others, right? And if that works for you, you have the lectures available, and you can jump in. Like if you have a few questions from the lecture or a few questions from this quiz, come in during the live session during office hours and jump in and ask them, then that's perfectly fine. You don't need to be here for the whole time. All right. Cool. You guys too. You stay safe. You stay healthy. And I'll see you Thursday. Bye.